So the gang's all here. What you eating, Grace?
Strawberries and cream oatmeal. It's my first time trying it. It's not bad.
Sounds like it should be good.
My mom got like a box of oatmeal, and there's like peaches and cream, bananas and cream, strawberries and cream, blueberries and cream. It's like, woo! So, you know.
I just eat oatmeal and cream.
Like fancy stuff.
Not really. My wife usually skims the cream. It's just usually oatmeal and milk.
Gotta do what you gotta do.
All right, so practice. Page 9. Bar graph on the previous page. Oops. Look at the picture. Look at the predict the population of the United States would be in 2010. Of course, we're past 2010, but still with this, we can keep going. Just a minute, gotta get my pen. So that's every 10 years, 2010, 90. That would be 1990. That would be 2000. And about here would be 2010. Now, you'd need a ruler to do this right. You'd have to take some measurements. But we'd be someplace right about here, which would be just under 300 million if that trend were followed. That's extrapolating. Notice that term, extrapolating. And if we're going to go in between, if we're trying to determine data points between two sets of data pairs, then we are interpolating. So if we asked what would it be in 1920, oops, that is probably 1925. If you're going to ask what it would be in 1920, then we would interpolate. We'd go between two sets. Determine the approximate population in 1935. Well, that's what they're going to do now. And by the way, I'm assuming that these, they don't really line up. And that makes it awkward, the fact that they didn't line these numbers up right. Actually, it makes it kind of impossible. Let's look at this bar graph. Why would you use a bar graph instead of a line graph? On this one, line graph is pretty good, but here they gave you some. Bar graph should be used for data that is not continuous. Well, this is pretty continuous data. It's a good indicator of trends if the data is taken over a sufficient period of time. So when comparing different groups, We're not comparing different groups, but we are trying to measure large changes over time. So that's why you might want to use a bar graph. Okay, now we are going to look at this bar graph. Notice that it's not continuous. We've got big gaps in here. And we've got a large variation between them. So this is not continuous data. According to the bar graph above, which is precipitation in Hartford, Connecticut, how many centimeters of rain fell on April 11th? So that would be 1 centimeter of rain on April 11th. Are you able to see any trends of this in this data? What do you think? Are there trends?
Well, from like the 3rd of April till the 7th of April, there's no rain.
Okay, but can we use that to predict anything about the future, or can we see a trend that we can make any dealing with? I mean, from beginning to end, yes, there was this period of time where there is no precipitation. And I guess we can call that a trend in one sense, but in another sense, it doesn't mean anything in the long run. It's just we didn't get any rain those however many days, 1, 2, 3, 4, 5 days. And that's 2 weeks. It just is what it is. We can't predict how much it might rain the following week. How much is it going to rain on the 16th? Extrapolate for what the rain will be for April 16th. If we could do that, we'd be making a fortune on the Weather Channel. So this kind of data isn't showing trends very well. Can a bar graph show a trend even if the data are not continuous? Maybe. We might even be able to find a trend in this bar graph if it was more than 2 weeks. If we did a bar graph, this would be terribly annoying. If we did a bar graph of the entire year, it might show us a trend, even though the data is not continuous. And we already talked about it can't be used to predict anything there. All right, now we're going to do a graph here. In 1989, the United States Department of the Interior reported that there were 360 endangered species of plants and animals in the United States. These endangered organisms include 32 species of mammals, 61 species of bird, 8 species of reptile, 5 species of amphibian, 45 species of fish, and you can read the rest of it. Construct a bar graph. Now, why would you want that to be a bar graph? They told you it was a bar graph. Why would you want that to be a bar graph? If they hadn't said, make this a bar graph, how would you have guessed that you would make it a bar graph?
Because it's different types of species. It's not just like one species continuously changing. It's different species.
It is not continuous. It's completely different species or groups of species. And it's not over a period of time. It's at one point in time. So species versus number on the endangered species list. Not continuous, random sorted data, not over a period of time, all adds up to bar graph, which I assume the rest of you made, like good boys and girls, but Josh did. So we've got, whoops. We've got number of species, so we've labeled the bottom. We've got a, we've labeled, I mean the side, we've labeled the bottom. It's way too fat. We have a key, no title.
I have I have the title right there. It's the underlined last sentence.
Okay. Total number of endangered species of animals and plants and animals. And okay. Oh, yeah, it says title. There you go. Wasn't looking close enough. There's your title. Assuming you counted the numbers right, which we're going to guess that you would be able to do that, that would be a pretty good graph. After an outbreak of influenza, the student gathered data on the number of students who became ill until she became sick on the 14th day of her study. And then she quit because she was sick. The information she gathered is shown below. Create a line graph, which, there we've got our data. And Josh also turned in that one. There it is. And so if you can't see the line, it kind of comes along like this. And we've got number of ill students. So we've got our y-axis. Time is on the bottom as an x-axis. That's time, again, always on the x-axis. Students who became ill with influenza, you may have added per day over a 14-day period, but this will suffice. The key is we're just talking about number of students. We only have one thing, not multiple things to keep track of. So looking at our graph, on what day were the most students ill? Right there would be day 6. By the way, it's also the largest number on our table. Tables, most scientific studies will give you the table and the graph side by side, and it's the same data, just presented differently. So sometimes you can go straight to the table. During which period of time, didn't mean to cross that off, did the most students become ill? Where was there the biggest increase? We've got day 7 would be about here. Day 5. Okay, 115 to 125. That's, and you know, we probably could have, I don't know, people weren't really becoming ill very much there. So yeah, this part of the graph would be where the most of them became ill. So probably from about here to about here on the graph. What day was the greatest number of students who were ill on the same day? Correct, that would be day 6, which is 127. Oh, what was the greatest number of students? Yes, 127 on day 6. Estimate the total number of students who were ill on day 15. So if we follow this trend, day 15 would be right about there. And that would be 32, 4, 6, 8-ish. So mid 30s. Sure, looks good. Looks good. All right. Any questions about this assignment? Okay, I kept you extra long the last 2 days, so I'm going to let you go early today. And we're going to be doing more graph and math stuff next week.
Mr. C,
Yes.
I made protein balls last night.
Okay, well, if you can figure out a way to make one come out of my screen, that would be great.
Okay, here you go.
Also, if you can do that, you get the patent on that and you become the person who makes Steve Jobs, rest in peace, and Bill Gates and all those guys look poor.
I'm going to figure it out.
All righty.
Wait, hold on. Pause.
You guys have a good weekend.
Wait, Carpenter.
Bye.
Oh, you can hear me. Okay. So I got an email from College Board yesterday, and when I read it, they were going through like some of like the pros of like this year's exam compared to the normal exams. And it's something about like no limit on 3s, 4s, and 5s, which I know there was a limit, but that's beside the point. And then it said something about everyone who does college level work gets 3s, 4s, and 5s. So are they saying that if you take the class and the test, you automatically get at least a 3?
No, I think that they're saying if they think that your answers on the test are college level, that you will have at least a 3.
Okay. They worded it confusingly.
Well, I don't think I got an email. I got something forwarded from Mrs. Anthony. I don't know if it was the same thing or not. I don't think I got one from the College Board per se.
All right.
Anything else? Okay, well, enjoy your protein balls, and have a good weekend.